So we are Team Thursday 29, and today we will be presenting our design for the Easy Grip.
For our design intention, we designed a device specifically for our client Elena, an artist passionate about painting and visual arts. She becomes fatigued while holding smaller, precise brushes, hence has limited fine motor skills. Our intention is to design a device which allows her to have freedom to do what she is passionate about with ease, which leads to our problem statement.
The problem statement that we developed was to create a mechanical solution for the client to use within their home that reduces fatigue and assists with fine motor skills while painting. We developed an ergonomic solution that would reduce the need for motor skills while painting, and we also aim to decrease overall fatigue from holding a paintbrush for an extended period of time.
We wanted to make sure that it was a device that was easy and simple to use. The idea from the sketch on the left was to make a larger grip based on the natural shape of the hand so that our client can grab and use smaller paintbrushes with her limited flexibility. The one on the right is a clay prototype made from their initial sketches that was used as a reference to validate the idea. It was easy and functional, and we wanted to improve the prototype, which led to our initial CAD design. With our CAD design, we made it an assembly with two parts, a wooden body and a cylindrical brush holder made from flexible silicone. This way the user could use multiple brushes and switch them in and out. This was the device shown to our science students in our peer review. Our final prototype was based on the feedback from this review as well as our own ideas.
So in this slide, we have a comparison of the refined clay model and the result of our design process in Autodesk Inventor. The main features of the device are shown using colored arrows. The main addition, other than being the refined shape, was the addition of a T-shaped bar. This was added with the intention of the device being more stable in the user's hand at multiple angles of use. Here we have showcased what using the device would look like at multiple angles, as well as different perspectives of our design in Autodesk Inventor. Despite the profile of our design being similar in shape to an average mouse, the design is not to be placed directly onto the writing surface. It is to be held above, with only the writing utensil making contact with the surface. The design principle of a mouse and this device is similar. Both fit the natural curve of the human hand, which then results in minimal grip strength being required to hold the device. The end of our design process required confirming the feasibility of using an altered grip to hold a writing utensil, or in our client's case, a paintbrush. Using the refined clay model of our device and my family members as test subjects, we were able to test how the device maintained fine motor skills. All five members of my family were tested, an example of which is seen here. The test involved writing the alphabet, their name, and drawing 3 shapes. This was done with and without the device. The results showcased that finer details were slightly more difficult, as shown by the general increase in the size of letters, but the ability to draw shapes was not greatly affected by the use of the device. All test subjects noted that the difficulty in using the device came mainly from its mass being made of solid clay and not from the altered grip. This proves that our design of the altered grip was successful in what we set out to accomplish.
So the main body of a component of our device and the T-bar on top will be made from balsa wood. Balsa wood has a low density, which makes it lightweight for the user to hold over a long period of time, and balsa wood is also easy to stain and varnish, which will help preserve long-term durability. This would be handcrafted in the woodworking shop at McMaster, with the T-bar slotted in and glued onto the top of the device. We will use tools like sandpaper and files to make it smooth and comfortable for the client to hold. So, the silicone paintbrush grip will be molded with a 3D printed mold and then glued into place on the main wooden body of the device. The silicone material allows for a high coefficient of friction against the brush to keep it in place while painting, while also the fins inside can flex around a range of different brush sizes. All of these material components have been sourced and included in our bill of materials, assuming we have access to the tools provided on McMaster's campus. In addition, the total cost of the project falls below the initially proposed budget of $100. Due to the messy nature of painting, we have included a wire brush for the client that they can use to clean out the inside of the silicone tube should paint get in there.
There are existing designs that allow people with grip problems to better hold marking tools. One major way our design differs from existing designs is that it is tailored to our client. The grip design on the right were designed to be compatible with varying hand sizes in both left and right-handed people, since they're symmetric. But we know our client to be right-handed and we know her hand size, so we specialize our design to be used specifically by her right hand. Our design is compatible with multiple brush sizes. The design in Figure 3 only accounts for wide tip paintbrushes as shown in the image, and the grips in Figure 1, 2, and 4 are meant for pencils, so their compatibility is limited for brushes larger and smaller than the average pencil. By contrast, our range of brush sizes is about 13mm to 6mm diameter brushes. That concludes our design presentation. Thank you for watching.